listening to Conversations with Richard Feidler on ABC Local Radio and the World Wide Web.
Can you imagine what your life would be like without balance, without a solid, intuitive sense of what's up and what's down? Dr. Daniel Brown is here now, and he's the only scientific researcher in the world working solely on a disease called the dizzy terror. It's a condition called Meniere's disease. 50,000 people in Australia are thought to be somehow living with it. The cause of it is unknown, but there is no known curative treatment for it, not yet anyway. But in 2001, a research committee was formed within the Medical Foundation of the University of Sydney, and that's where Dr. Daniel Brown works now. Daniel, hello.
Hi, Richard. How are you doing?
I'm well, thank you, sir. This really freaks me out.
Yeah.
This whole losing the balance thing. Is it like bed spins? Is it like when you've had too much alcohol to drink and come home late at night and the room is spinning? Is it like that?
Close to that. Try magnifying that by about a factor of 10 and you're probably getting close to what these people go through. And then have that go on for a period of about 6 hours and you're getting a sense of feeling what these people go through about 5 or 6 times a month.
Daniel, bed spins almost has me weeping with self-pity. 10 times worse, you say?
10 times worse. Add on to that a number of other symptoms, all sorts of bad stuff like a roaring tinnitus and a perception of the world closing in around them, pressure in their heads, pressure behind their ears, all sorts of other nasty type symptoms as well. And you've got to feel for how desperate these people are. These random violent attacks of extreme vertigo are essentially the number one distressing symptom of this disease.
Most of us know that we keep our balance through something called the inner ear. And it just strikes me how little all of us know. I mean, I have a picture in my head of something sitting in the middle of my brain that looks like an ear, and that's what the inner ear is, but it's not like that at all, is it?
No, it's amazing just how many people just have I've never even thought about what's behind their own eardrums, and I think that's where the level of their knowledge about the way they hear stops. What's behind the ear is actually quite a unique and complex structure that allows us to both hear a huge range of frequencies with a great amount of sensitivity, and it allows us to coordinate our own movements and our own sense of gravity and position in the world throughout the day.
Well, what does it look like in basic terms?
You've got basically two structures. You've got the hearing organ, which is the cochlea, and that's very easily described as a snail-shell type structure. And in that cochlea, you've got basically a trampoline that sits between 3 fluid-filled chambers, and on that trampoline, you've got a number of little hair cells. And
is that the eardrum? Is it?
The trampoline is basically you've got the eardrum that's connected to the cochlea through some middle ear bones, and the trampoline in the cochlea spirals around with the cochlea, and on that trampoline you've got little hair cells that detect pressure vibrations, and depending on the frequency of the sound, it'll vibrate the hair cells at different regions throughout the cochlea. The other part of the inner ear is the vestibular system, and there's a couple of components in the vestibular system. You've got the semicircular canals, which are 3 large looping structures. Again, they have a certain component in them that has hair cells in it, and they detect rotation of the head. And you have 2 other compartments, fluid-filled compartments. You have hair cells again, which sense gravity and send signals to the brain about the sense of balance.
So we get our sense of balance from these, tiny little hairs.
Absolutely.
With what fluid rubbing up against them. Is that what it is?
Our sense of rotation basically comes from the semicircular canals. You've got hair cells in there, and when the head rotates, the momentum of the fluid results in a bending of the hairs on these little cells, essentially.
And that gives us the information.
So
why don't I feel that? Why don't we feel? I mean, when we know how to balance, don't we? But we don't. And we have a kind of sense of it, but it's I'm not feeling that fluid running up against
that's because you're sitting still at the moment. If I spun you around on a chair for a while, then you'd feel it. And certainly every time you move your head and you get that acceleration of movement, then you are feeling that. That's exactly what you're doing. Your brain's interpreting those rotations as a movement.
So everything that keeps our balance, the thing that keeps our balance, it comes right down to this really fine, utterly tiny, incredibly subtle, hairy bit of the
Absolutely.
That's it, isn't it?
It's all got to do with fluid pressures and the mass of gels that are above the hair cells as well. That's to do with their sense of gravity. But that regulation of fluid pressure in the inner ear is absolutely vital to our normal vestibular and auditory function. and yet we have very little idea about how that's performed by this unique inner ear structure.
So what happens to people with Meniere's disease then?
Well, it's mostly commonly thought that that Meniere's disease results from an abnormal production of fluid in these inner ear chambers that surrounds the hair cells.
And, too much?
Yeah, too much fluid, which sort of, we believe, creates an abnormal fluid pressure and displaces the hair cells, so that in the cochlea, this abnormal fluid pressure displaces the hair cells and gives us a number of different auditory percepts, such as tinnitus and hearing loss. Whereas in the vestibular system, it's thought that this abnormal fluid pressure might cause all of the vestibular dysfunction that's associated with the disease.
A couple of years ago, I had an astronaut on Conversations, a doctor who was sent up onto the space station. I think it was the space station or the shuttle. Anyway, part of his brief was to investigate why astronauts suffer from what's called space sickness, right, which is this profound sense of dizziness, nausea, not knowing what's up, what's down, that happens when you're in zero gravity or very, very low gravity. And with a bit of mucking around, he discovered the way to treat it was with very large doses of Phenergan. That actually seemed to help. What's going on there? Is that something akin to Meniere's disease?
It almost. When you're in zero gravity, the hair cells which detect gravity in the inner ear actually work on the differences in the gravity of the structures that are above them and the differences in gravity of the fluid. So when you're in a zero gravity situation, the hair cells have got nothing to grab onto, essentially.
It's horrible, apparently.
Horrible. Yeah,
he says the first thing is you're worried you're going to die.
Yeah.
And then the next thing he says you're worried you won't.
Exactly. And now you talked about Phenergan. A lot of these drugs are essentially just seasickness tablets. They're the sort of things that treat nausea or the sense of vertigo. They might suppress the reflex to vomit. So essentially all they're doing is suppressing the nausea that's related to this sense of rotation or abnormal sense of gravity.
So it's just treating the symptoms.
Yeah, it's just treating the symptoms. It's not curing. It's not changing anything that we know of. It's not changing anything in the inner ear itself. They're most likely just having effects in the brainstem to suppress what we believe to be an abnormal input.
I'm speaking with Dr. Daniel Brown, who's a researcher into the cause and treatments for something called Meniere's disease, which is sometimes called the dizzy terror, a disease that affects about something like 50,000 Australians, where they lose a sense of balance and the inner ear doesn't seem to function properly. So with people with Meniere's disease, does it come on all at once, Daniel, or does it just creep up on you?
There's a number of ways it can come on. It actually can either build up over the space of about 5 minutes. So they'll be walking along the street relatively fine, and they'll then start to feel a very slow sense of rotation. They'll get a pressure behind their ears, and then all of a sudden, within 5 minutes, they'll have this absolutely severe rotational vertigo, and they'll be rolling around on the ground. And when it seems to be that when it builds up slowly, it lasts for even longer, so it can last for about 6 hours.
Oh, no.
Yeah, absolutely. That's the point. I mean, we've all been dizzy at one stage in our lives when we're younger, probably. But if you can imagine having that sort of dizziness, times it by 10 and have it last for 6 hours, you get a sense of what it's doing to these people. Now, that's, we talked about, does it come on fast or slow? It does come on fast, and that when it comes on fast, we call that a drop attack, because that's the situation where the person will be walking along fine, and without warning, they'll just drop to the ground. Their sense of balance and their sense of orientation is just completely lost. Their world is turned upside down. They're on the ground.
And what, vomit?
Yeah,
continuously?
Vomit, absolutely. And you can imagine that puts them in a pretty dangerous position. If they're driving a car, or if they're walking up and down an escalator, or there's a whole number of situations they could be in where to have one of these drop attacks is extremely dangerous for them. So they have to manage that into their own lives and be aware of it constantly.
Then you must meet many people, I suppose, who have this condition. Tell me about, I don't know, some of the people you know, some friends of yours who have Meniere's disease and how it affects their lives.
I've started meeting several sufferers over the last couple of years. Meniere's disease typically starts to affect people in their 30s, but it can certainly affect people when they're much younger. And I remember meeting a young girl about 2 years ago who was around 15. I think her name was Elizabeth. And she had full-blown Meniere's disease. And she's a 15-year-old girl having to deal with this sort of symptoms when she's trying to get a schooling finished. She's going through TEE, and yet she's got to be constantly aware that at any time she can collapse and be rolling around the ground for 5 or 6 hours. Add on to that all the symptoms she's going to have to go through as well, and this feeling that symptoms are only going to get worse, and it's extremely distressing for those sorts of people. Trying to convey this sense, when they look fine, this sense that they're having to deal with this awful disease is pretty tough for them.
Do we know why some people get it while the vast majority of us don't?
No, we do not.
We don't?
So, no, there's no simple measure for it at the moment. We really don't have a good understanding of what's causing it. And
it could be genetic, it could be environmental, It could be, a virus or something?
It could be something like that's been suggested. It could be a virus. One of the first things we have to do is come up with a diagnostic test for it.
Why do we know so little about it?
We've known about it for more than 100 years, that's for sure, but it's such... As with many things, with the inner ear, it's encased in bone. It's hard to get to. So determining how the inner ear works is tough enough as it is, because as soon as you get into the structure to try and work out how it works in the first place, you've completely buggered it up. So try and work out what's gone wrong with it is even tougher.
So as the disease progresses, you have these attacks, and then you get tinnitus, the roaring, ringing in the ears. Yep. And what other symptoms?
Fluctuating hearing sensitivity, which progresses from a very low frequency hearing loss to a broad frequency hearing loss of about the order of about 60 dB, which is about the level of having your finger stuck in your ear. So essentially, these people basically will say in their affected ear, they're virtually deaf. They'll have all sorts of perceptual changes that probably are related to the reduction in their vestibular function, so that changes in their visual field can trigger their attacks or make them feel unwell as well.
Or what does that mean? Does that mean like the sense of where they are in the room, or the walls closing in on them?
Yeah, absolutely. All that sort of stuff. I mean, these people often complain that they can be driving along in a car with the sun shining through the trees will trigger their attack, and they just can't deal with that sort of thing. And that relates to the fact that with a rapid change in their visual field, you get your sense of orientation from your vestibular system, but you also get it from your sense of vision and also your muscle spindles and the rest of your body as well. And so a mixed messages of your sense of orientation that are coming from this abnormal vestibular activity mixed with what your brain is seeing, or your eyes are seeing, often leads to all sorts of strange phenomena such as the world closing in on around them and a few other type perceptual symptoms as well.
So do people become progressively deaf then? And with deafness, is there relief?
No, there isn't. Unless there's things like hearing aids that you can use to crank the sound level up. But at the moment, we don't have any drugs or anything that can alleviate the ongoing reduction of hearing sensitivity.
The inner ear balance. Are there surgical techniques that can actually help with that?
There's no surgical techniques that are going to stop the decay of their sense of balance from their affected ear. But if that ear is firing abnormally or has abnormal activity, a surgeon can go in and essentially section or cut that vestibular nerve so that they are getting no signal from that ear whatsoever in terms of balance. And it's been shown that over time, people will learn to adjust their sense of balance to do without that particular ear, and they get on just fine, or at one level they get on just fine.
How about you, Daniel? How did you become the researcher into this? Are you the only guy who's full-time working on this condition at the moment in the world?
It would seem so, yes. At the moment, we are developing the very first research laboratory in the world which is completely devoted to Meniere's disease research. Certainly, there are a number of research laboratories around the world who might dabble a little in Meniere's disease research, but we're the first ones to be totally focused on it.
What interested you in this? Obviously, you'd specialised this area of research on your PhD.
Yeah.
Why this area?
Growing up, I didn't know anyone with a hearing loss, and I didn't know anyone with Meniere's disease. So at one level, I got into it for selfish reasons, essentially, because I found the inner ear and the way it worked extremely interesting. I mean, I guess growing up, I just liked puzzles and trying to work out how things worked. And when I was very young, I made the decision to get into neuroscience, and that stemmed from essentially seeing a Four Corners program where I'd watched a program about scientists regrowing nerve cells in a dish, and I was about 14 at the time, and that got me extremely interested in science. And I thought, if people can regrow nerve cells, and all of a sudden, blind people can see again, and quadriplegics might be able to walk again. I was naive at the time, and I now know that there's a lot more to it than that. But I think I got
to find that Four Corners episode and play it to my own kids.
Exactly, it got me extremely interested in science and neuroscience, and then from there I went to university, found that physiology was the most interesting subject to me, and physiology is just the study of how the body works and all sorts of organs. In my undergraduate studies, I was getting lectured about the inner ear and the cochlea and how we hear, and I found that extremely interesting. I managed to have an extremely good lecturer at the time, Dr. Rob Patuzzi at the University of Western Australia, and his passion and knowledge about physiology and how things work in general was just amazing, and I think I was a bit gobsmacked by that, and that completely got me even more interested in the inner ear, and I managed to be able to do my postgraduate studies with him as a supervisor, and I think it put me in a position to have some of the best teaching in physiology that I could have had anywhere in the world.
And so from there you went over to the United States, to St. Louis, Missouri.
Yep.
No one ever goes to St. Louis, do they? It's not like, the number one destination.
No, it isn't. No.
Well, and you were able to do research there, but how did you find living there for all those years?
St. Louis is probably not the number one tourist destination of the States, that's for sure, but it is, isn't it? It's not a bad place to live. I think for me, growing up on the west coast of Australia, I think that the biggest hurdle to overcome was the sense of being landlocked for 2 years. I think previous to that, I don't think I'd gone more than 14 days or so without seeing the ocean. So all of a sudden, living in the middle of America was certainly something to get over.
Yeah, it's like a 4 days drive to the beach, isn't it, really?
Yeah, absolutely. Yeah, so it was pretty difficult. The people are very nice. It's a great place to live. It gave a good insight to normal American life as well, and normal Americans. Because certainly if you go to places like New York, I don't think you get a good impression of what America is really all about.
No, you don't. You get a good impression of New York instead.
Yeah, exactly.
So they're pursuing research into the inner ear and how it works in Meniere's disease. You and a colleague we sort of became, I suppose, right on the forefront of research into this condition. Yeah. What do you suspect is going on? You've got a hypothesis floating around at the moment. Yeah. What do you think is going on with Meniere's disease?
That's while I was in St. Louis, I was researching with Professor Alex Salt, who's a world-renowned expert on inner ear physiology and in Meniere's disease. And one day Alec was doing a series of experiments where he was investigating methods of delivering drugs to the inner ear for a number of reasons. And he was essentially squirting a gel into a certain region of the cochlea, simply for the purposes of delivering drugs to the inner ear. And I happened to be sitting in on this experiment, and I noticed that the responses that were coming from the ear all of a sudden changed, which we hadn't sort of at one level expected to occur. And I pointed this out to Alec, and we noticed that one of the biggest things that was happening was that the ear was becoming hypersensitive to very low frequency sounds, called infrasound, which is essentially the frequencies below 20 hertz. We don't normally hear those types of frequencies.
Well, like ultra bass noise.
Ultra bass noise, very like 4 or 5 hertz sort of stuff.
This is stuff that's around us, but we can't hear.
Absolutely, it's constantly present, but our ears filter it out. Similar to on the back of a big subwoofer, you might have a hole at the back of the big subwoofer. And the purpose of that hole is to equalize the pressure from in front of the cone to the back of the cone. It doesn't equalize high frequency pressures, just very, very low frequency pressures, so that every time someone closes a door in the room that the speaker cone doesn't get displaced and doesn't distort. We have exactly the same sort of mechanism in our own ears, and it just happened to be that where Professor Salt was injecting the gel was blocking up that hole in our inner ear. So exactly what he was doing was, by blocking that hole, he essentially made the hair cells, or if you like the speaker cone, hypersensitive to very, very low frequency tones. And we immediately realized the importance of that, because one of the things that happens with Meniere's disease is you get a bloating of the inner ear compartments due to this abnormal level of fluid volume in the inner ear. And that bloating is particularly noticeable down at the apex in this region, which acts as a low-frequency shunt. And quite often, you can see that this bloating leads to a blockage of this area. So we thought through the process a little bit more, and we realized that Meniere's disease sufferers should be hypersensitive to infrasound simply because they've got a blockage of this particular pathway. And we went back to a number of experimental results where we had induced a hydrops, when a hydrops is a fancy term for talking about this abnormally large volume. And we found that indeed, when you have a hydrops or abnormally high volume, the ear is hypersensitive to infrasound. We then went back on to have a look at some of the things that were triggering people with this disease, triggering their symptoms. And it was things like riding in cars with the windows down. They didn't like that. They said that exasperated their symptoms. weather fronts. They don't like weather front. People with this disease don't like weather fronts because
change in barometric pressure.
Change in barometric pressure. We began to piece it all together to suggest that their symptoms are probably related to this blockage of the certain pathway in the inner ear. Now, we don't know what's causing the abnormal fluid volume in the first place yet. That's one of the things we've got to work out eventually. But if we can get a handle and we can demonstrate that their symptoms, these attacks of vertigo and the fluctuating hearing loss, stem from the fact that they've got this blockage of this pathway in the inner ear, then we're on a good track to developing new techniques to diagnose Meniere's disease and to treat it as well. So we think we're heading in the right direction, and if we can demonstrate that this year through recordings that we're going to be making with an otologist here, Professor Bill Gibson, we'll be definitely on the right path to developing better treatments for these people.
Daniel, treatment still seems a long way away, doesn't it?
Sort of. Hopefully not. If we can develop a technique, a tool, if you like, to measure hydrops in these people, then we can start to develop more accurate treatments for them. And if we know that this blockage of this certain pathway is the cause of their symptoms, then we can look at treatments that alleviate that blockage as well. So we can start to gear our treatments to unblocking that particular pathway. So when you say a ways off, maybe 3 or 4 years, hopefully, just as a rough guess. Now, that's just the treatment side of things. In order to come up with a cure for Meniere's disease, we first have to understand what's causing the abnormal fluid volume in the first place. And as yet, we don't have a good feel for what's causing it. There's definitely some ideas out there, but until we know what's causing that abnormal fluid volume, we can't yet develop a cure for this disease. So a cure for it is probably a lot longer off yet. With the research we're doing at the moment, we have to, and the research laboratory that we're developing, we have to get that laboratory set up to a stage where it can become self-sufficient and it can become a long-term type research laboratory.
Are there many sufferers all around the world hanging on what you do at the moment?
Absolutely, absolutely. And in particular, it's obvious in Australia that sufferers certainly want this research to go ahead, and they're certainly desperate for this research to come up with a better treatment and possibly a cure. The Meniere's Research Group of Australia have managed to raise around $400,000 to financially support this research. And the Meniere's Research Group of Australia are basically a committee of volunteers who've done a fantastic job as they're faced with the arduous task of raising the funds to support this research. In particular, I'll just name drop here, Bruce and Juliet Kirkpatrick have done a fantastic job for raising the awareness and raising the funds that we need at the moment. But having raised this amount of money it shows that many sufferers are desperate for research into this disease.
Are there plenty? I mean, I mentioned a figure that's an estimated figure of around 50,000 people in Australia who have Meniere's disease. Are there likely to be many people who just have it but aren't diagnosed?
Absolutely. Diagnosing Meniere's disease is a really tricky thing. At the moment, it's purely diagnosed on the people having a number of types of these symptoms that we've talked about, and yet these symptoms can occur with other types of inner ear disorders as well. So clinicians that diagnose Meniere's disease have got a pretty tough task. People might come into the doctors one day and they'll say, look, I've had an attack of vertigo and I've got some tinnitus. And the doctor might say, oh, okay, you may have Meniere's disease, you may have something else. There's a number of things you could have. So because we don't have this tool for accurately diagnosing Meniere's disease, there's a large amount of misdiagnosis of it. And while we know that somewhere in the order of 50,000 Australians have this disease, there have been estimates that number could be as high as 200,000 simply because our diagnosis of it yet is not very good. So diagnosing it is a hard task to begin with.
Well, Daniel, I hope I'm speaking to you in a couple of years' time when huge leaps and bounds have been made into your research. Thank you very much for coming in today. Great to meet you.
Thanks very much, Richard.
You're listening to Conversation